Okay. All right, friends, welcome. My topic is profiling Android apps. Yeah. So, profiling, we'll be talking more in depth about it. What is profiling? What is performance and everything. Before that, I think it's more important to know who am I? Why do I get to talk about this? Am I qualified enough to talk about this? So, yeah, my name is Sagar. I also go by Sagar, Sagar. I will not hold grudge on anyone who mispronounces my name. It's fine. I'm a staff Android engineer who works at Vivint Smart Home and has been doing Android apps for a while now, almost 9 years. I write about performance in Medium. You can find me in Medium at Saga the Dash. I'm a performance junkie, as I like to introduce myself, dabbling around like CPU profiler, memory profiler, a little bit more on that on later. This is what our agenda looks like. We will be talking about what is profiling. We'll be showing around like what is CPU profiler in Android Studio, what is a flame chart. Yeah, that sounds interesting, I know. Memory profiler in Android Studio, and we'll wrap up with talking about memory leaks and all. Okay. Now, if you were to try out what I'm about to show, I would recommend that you need to have a system with at least 16 gigabytes of RAM. Recommended is 64 GB because using profiler tools in Android Studio is tricky. It might lead to crashes and everything. And other important thing to keep in mind is we cannot really talk about performance or profiling of an Android app without having a production ready Android app. Generally, while giving a talk, we talk about beginner level stuff. But the good thing is the good folks at Firefox team, they have open sourced their entire app. Their app is being used by 100 million users. I refer it from time to time. It is available in GitHub. You can see the link over there on the screen. The code name for the app is Phoenix. And yeah, for this talk, we would be exploring their code base and we'll be figuring out how a production mobile app looks like. How do we find out performance bottlenecks? How do we learn visually if you were like completely new to a code base? Is there a way how you can learn about what is happening behind the scenes without reading the code first? By just looking at some charts or some colorful, beautiful flame charts and stuff like that. All right. Now, as I mentioned before, we cannot talk about profiling without talking about performance first. Now, this is the mental model for performance which Google advocates for Android apps. If you were to move your Android app from the beginner stage to an intermediate, or to like you are planning to advertise your app and try to gain more revenue by making more users install the app, eventually you would be focusing upon how to improve your performance of the app. Now, the entire mental model for a performance is divided into three pillars: inspect, improve, and monitor. And the cycle continues. For the purpose of this talk, we would be focusing upon inspect, and that is what profiling is all about. It is a process of measuring the performance of an Android app in order to identify bottlenecks. Because if you are having an app with 2 million or 5 million users and you see Play Store reviews and users would simply give a blast towards saying that the app is slow, user reviews are not helpful in my opinion. They would simply say, "Ah, this screen is slow." And how do you go about and identify all of those things in the code? So the good folks at Google have created two different tools in order to identify all of those performance bottlenecks in the app, and that is inbuilt inside Android Studio. So for the purpose of this talk, we would be focusing only on the CPU usage and the memory usage. And we would be using the inbuilt CPU profiler and memory profiler, which will help us to diagnose issues such as long operation times, slow frame rates, and memory leaks, and stuff like that. When I say slow frame rates, it's all about like gamers will understand frame lag. If you see like a drop in frame rate, you're playing around a game, and then all of a sudden your character is at one position and the next second is like flying in the air. That's what a frame drop is, and that's a slow frame rate. All right. Before we dive into the Android Studio part, let us first understand what a CPU profiler is. It's a tool that analyzes the performance of an app by measuring the amount of CPU time spent by the different parts of your app. If you have like a massive code base, just like a Firefox code in their mobile app, you would be having like almost 100 files and like millions of lines of codes doing the stuff to make things running smoothly. So a CPU profiler helps you to identify. Go on. Yeah.
There's a request to put it in full screen.
Oh, okay, cool. All right. Thank you. Awesome. I hope that's better. All right. So a CPU profiler ideally helps us to identify the number of method calls, the amount of time spent in each method, and the number of CPU cycles used. Now, I would be showing how to use CPU profiler in Android Studio in a while, but you can find the CPU profiler from View, Tool Windows, and followed by CPU profiler. Let's now understand what a stack trace is. I'm pretty much sure almost all of the attendees over here are familiar with this term, what a stack trace is. But for the love of technology and for the love of our understanding fundamentals and basics, a stack trace is actually kind of like a building block which shows a sequence of method calls. For simplicity, let's consider you have methods named as F1 and then it calls F2 followed by F3. That is what a stack trace will provide a visual representation of your entire code. Right? So you do not have to go through all of the lines of code to figure out which method is calling the next one and so on. Now, an extrapolation of the stack trace is called a flame chart. It's aptly named because it provides a visualization technique which shows, I would say, a hierarchical structure of a program's execution over time. And since it deals with CPU run hot, you would find tons of memes on the internet which shows like if you run your cell phone or laptop for a while, you can make omelet on top of it. So that's why the color schemes and everything. Uh, there are three color schemes when we talk about flame charts in CPU Profiler. There's yellow, there's orange, and red. Yellow means it's less hot, medium means medium hot, and more hot. So, what does hot mean? It means like the amount of time spent by CPU in executing your code. You may build a fancy Android app which is using all the ML libraries to do face recognition and everything, but ultimately, if it is going to utilize a lot of CPU time, it is going to affect the battery usage of the app, and that will not be ideal for the users in the long term. Now, intuition might say that we need to focus on the red parts when we see a flame chart, but that's not the case because at the end of the day, it all comes down to how much time a particular operation is being taken by executing a code. So ideally, when we are visualizing a flame chart, our focus should be optimizing the longest block. Now, the colors displays the intensity, how busy the CPU is, and the length of a block signifies how much time the CPU is taking in order to execute a particular operation. All right, yeah. Now that was all the theory part of CPU profiler. Now let's get to the fun part. And let's see how all of these things look in Android Studio. Now, I have already set up the Firefox open source code base in my Android Studio. As I have recommended earlier, you need to have at least 16 gigabytes of RAM. 64 gigs is a big plus if you want to try it out yourself. But let's go ahead and see how a CPU profiler looks like. Now, there are two ways how you can launch a CPU profiler for your app. Number one is you can simply launch your app, and I have connected my device over here, and it is being mirrored on the Android Studio screen. But there are two options how you can run a CPU profiler. Number one being you go to the profiler option, which is at the bottom of the menu, and then you click on that, and then you see a plus option, or if your app is already running, you see the profiler comes into action automatically without me doing anything. So you see the Android profiler being divided into three different components: CPU, memory, and energy. For the purpose of this talk, we would be talking about CPU and memory. I feel like if we identify all the performance bottlenecks in using CPU or memory profiler, it would eventually be helping us in identifying issues with energy profiler as well. We do not need to delve specifically into energy profiler for now. Now, the second method of launching a profiler, which is the recommended way, is how would you profile the amount of time that is being taken by your app from startup? Now, there is a caveat if you launch your profiler over here, because when you launch your app in the emulator and then you take some time coming over here on the profiler window and then attaching it, you miss out on that window of time which is actually being spent by the app for startup time. And that will not serve us any good. Like, we are interested in finding out what is going on when the app starts up. So the second method of launching a CPU profiler would be go ahead to run, and you would see edit configurations. And then you will see multiple options over here, general, debugger, profiling. We'll be going to profiling, and we will be enabling this checkbox, start this recording on startup. We select CPU activity, and from the drop down, we would be selecting Java Kotlin sample legacy. There are multiple options: system trace, call stack. A system trace would actually help you identifying how your Android app interacts with your Android operating system in general. But for the purpose of this talk, we are more interested to find out what is going on in this app itself and not how the app is interacting with the operating system. So we'll be selecting Java and Kotlin with that sample. And let's save this configuration. Let me go ahead and stop the existing profiler so that we don't get confused. Let me delete all of these things. And now what I'm going to do, I'm going to run, and I'm going to click on profile. It's going to ask the app option, and then I select app. Now what it is going to do, it is going to relaunch the app. And let's see, in the profiler, there should be another profiler coming up, a running profiler. If it doesn't, then we click on the plus button over here and select the process which is running. So let's go ahead and do that. Yeah. So over here, you can see the app has already started the Java Kotlin method sample legacy stack trace. Now I'm going ahead and clicking on stop. Okay. This might be overwhelming, but if you know how to navigate around this entire chart, your life is going to be really easy when you are trying to navigate around like massive code base. Now, all of us know our app ideally executes on multiple threads depending upon what you are trying to launch. We have like launcher thread, and depending upon your third-party libraries, if you are trying to load images from Glide and retrofit, all of those would be having different threads. But for the purpose of performance, we are always interested. Our goal as an Android developer would always be to focus upon to reduce the amount of time that is being thread of the app. Now, by default, when I clicked on stop on the CPU profiler, you see the entire CPU usage is being highlighted. Ideally, people use like a secondary bigger display to zoom in and zoom out the entire CPU stack trace. But we're gonna see how to take it like a smaller section of the graph at a time. So on the right hand, the entire analysis, how much I spent from the startup till the point when I clicked on stop on profiler. You see the duration is 32 seconds, and there's the flame chart. Now this looks chaotic for now because a lot of things is being captured over here. So my recommendation is we always start small. By that, I mean reduce this window size over here on the top. You see the CPU usage? Go ahead and reduce it. And then that you get to see like when move along the window to like different sections of the graph, you would be seeing meaningful information starting to come up over here. Let's see what we can find from here. Okay. that even further. Okay, let's see. So to start navigating a code base for the first time in your life, like for this Firefox app, your first step would be to identify where does the operation start from. Now, if you would be knowing this, like how to identify a main activity of the app, but I'm going to show this for the purpose of like completeness. So we open the manifest file and we search for the main and let's look for this. Yeah. So whichever activity has like in inside the intent field category launcher, that would be our main activity. In the sense like this is where all of you and the name for activity. So now we have discovered what is the name of our main activity. Let's see if we can find that information in our CPU flame chart and see if we can use that for visual learning. Let's see. Uh, Let me see if I can reduce it a little bit more. And then over here, if you see if I'm hovering over here, you can home activity.onCreate. Now, almost all of the attendees in the sessions definitely know that an activity has like different lifecycle methods associated to it, on create, on start, and all of those things. If I click over here and come up to the analysis section over here, you see that particular method being highlighted. And let's move on. And you can see like different details is more of like, yeah, something related to like CPU execution cycles and etc. But I'm more interested in finding out the flame chart. So let me see if I can increase it over here and let me see if I can zoom it. Now, as I was explaining earlier, a CPU chart has like three colors like yellow, orange, and red. The red one signifies what are the CPU intense operations, and the length of a block signifies the amount of time that is being spent on executing a particular method. So if I were to find, if I were to tell you like what all stuff is going on in the code without looking any of the lines of code, this chart over here is my friend. I can see like the on create method over here calls like subsequent methods, inflate method, and then create view. Furthermore, up on the line, we have like setting up the navigation controllers and stuff like that. Similarly, we can find out more information on start method as well, and then zoom on to those individual methods to find out what all is going on that. So this actually provides us those visual means to find out what how does the execution of the code looks in the background. Now this gets really interesting if you were to find out what happens before your main activity is being launched, because right from the time when you click on your app icon in your device and then home activity is launched, there is a certain window of time where the app does all of its pre-setup, right? So people who are like seasoned developers in the Android world, they know that we have something called as an application, which ideally launches before your main activity in the app and then does all of the setup for your app. So if I were to find out information for the application class in the flame chart, let's see how we can do that. Let me come up to uh, the trace window. If I can find, yeah, Phoenix application.onCreate, and let's go to the flame chart. Okay. And this is where you get to see what sort of individual operations is being created by your app before the user sees the first screen. You see the application class is setting up the leak canary, which is like identifying memory leaks. It initializes Glean, which is Mozilla Firefox own performance measurement library. And then we have like restore downloads. And so yeah, this is how, like, being a seasoned developer, you should be curious about like how does all of these individual components of a given method are interacting with each other. And yeah, for example, like I'm curious about like why does the app need to spend some time restoring downloads. And there is a quick way how I can navigate to a particular method directly from the flame chart. Is click on the relevant block in the flame chart, double click it, and then you'll see jump to source, and it takes me to that exact method where this is being called. And this is like really useful to navigate around in the code base. Like you do not have to, if you are a first timer in code base, you do not have to spend time figuring out, oh, this is method 1 is being called after method 2, method 3 is being called after method 4. Flame chart does all of this visual representation of that information for you. So you can go to restore downloads and dig in further how much time is being spent in what sort of operations, and do your optimizations in the app accordingly. Any questions till now?
We're good.
Cool. All right. Yeah, so let's see if I can show you one remaining thing in the CPU profiler. Oh, there used to be a jank frames.
Jank? Really?
Yeah, UI janks.
Nobody wants that.
Look, it's actually a relevantly like a recently introduced feature in Android Studio. Let me see why it did not show up. It should be showing up like the frame rates or the drop in the frame rates. Yeah. Let's see. Let me relaunch it. Okay. Now this time, let me. Oh, and one more thing which I forgot to tell, like you can export your recorded your recorded trace file. Yeah, you should be able to export your recorded trace file and then saving it and sharing it with your team members, which is definitely convenient, because using CPU profiler or memory profiler in Android Studio takes up a lot of resources, and it becomes easier down the line. Yeah, so before moving ahead to the memory profiler, let me quickly check if I can show you guys the UI janks, which I'm talking about. So for that, this is executing. This is a new session for profiler. Now, let me go to CPU. This is being there. And if I were to, let me search in Google. Yeah, I'm just typing in hello in the app, and it does a simple Google search. Oh, there's no internet connection.
Just got to right link your apps.
Broadcast here. Okay. Let's search for Phoenix. There we go. Okay. I might have to redo it because I did not click on record. So I'm going ahead and click on record over here. Let
It's
me-
funny how Ella brings up
Yeah.
Adele's song.
There you
How
go.
about saying hi?
All right, let me go ahead and this. Oh, I still don't see the Jank section. All right, third time's the charm. Okay, let's go to CPU. And this time around, let me go ahead and select system trace in Kotlin method sample. And I'm clicking on record. And I'll be doing hello. Let's see. There we go. The janky frames. The name is funny. I know. Every single time someone heard for the first time, like Google decided to call them as janky frames, they have had a laugh. Like, really? Janks? Okay. Yeah. So, a janky frame is the technical term which we describe a frame drop or slow frame rates in an app. So, for example, people who manage apps in Play aware of like how ANRs get recorded, and most of the time ANR or Android not responding, as we call them, happens due to like janky frames or like slow frame rates. Now that happens for multiple reasons. It could be like you are doing a lot of stuff in your main thread, which is causing your app to behave sluggish. So the idea of analyzing janky frames is the same. You reduce your CPU usage window to like a smaller size where it becomes manageable to dig in deep into it. And then when you click on it, it will be showing you the details of that frame. So you can go ahead to flame chart, and then it will be giving you all of the necessary methods which are over there. And then you can go on to that exact phase where this jank is being uh, yeah, discovered. Okay, let's see. Okay, now let's move along to the second portion of this talk, that is memory. As I was telling before, like focusing on CPU and memory, like these two are the most important pillars in any system's app development, be it Android, iOS, or any other systems app. If you were to focus on improving the performance of your app alongside of these two areas, it will automatically take care of improving battery usage for your app or like making efficient network calls and all of those things. So as its CPU counterpart, a memory profiler is also a tool which analyzes the performance bottlenecks in your app related to, as the name suggests, definitely the memory usage or the amount of RAM that your app is consuming. Uh, it provides information about the number of objects which your app is using or your code is using, the amount of memory consumed by those, and the number of garbage collection events. For the fun of it, I love delving into basics. For those of you who are still confused by the term GC or garbage collection, it means like whenever your code has completed execution and the operating system does not require your code, there's a in simple words we can call it like purge operation. They get removed to the trash, and then that amount of memory which has been purged gets reused by your next screen or your next piece of code. Now, using a memory profiler can be used to identify memory leaks, uh, reduce reducing the likelihood of crashes during out of memory errors. We're gonna be talking about out of memory errors in a while, and yeah, overall improve the performance of the app. Like we discovered CPU profiler in Android Studio, we follow the same pattern. Go to View, Tool Windows, and Memory. Okay, now let's understand what an app heap is. Now, your app, like which irrespective of the lines of code which you have written or the number of files you have, it always has a dedicated and hard limited pool of memory, and your app cannot exceed than that. The exact, and that's called the heap size. Now, the exact heap size limit varies between devices depending upon how much RAM you have. These days, even though Android devices have, like, I would say 12 GB of RAM or whatnot, but only a limited amount of memory is allocated to an app. Typically, it would be like 32, 64 MB of RAM and everything. And that's how the entire app's lifecycle keeps on purging and repurging those memory objects and making sure your app is performing in an ideal state and everything. That is taken care by the operating system. But sometimes, if your code is not optimized, there would be an out of memory error. Meaning, when the garbage collection event is trying to purge your code, trying to remove certain objects, and they are being clingy, they're refusing to go away from your code, then that is where an out of memory error occurs. The operating system keeps on piling more memory to it. If your app has already occupied 64 MB of the rest of the dedicated app heap limit, and you're trying to add, let's say, 2 MB more, there would be an out of memory error and there is no going out of it. uh yeah, and that's what, like, memory leak is like it's a term associated with out of memory error. A memory leak is a type of a software bug which causes your app to fail uh, while releasing memory when it no longer needs. As I said before, like when the garbage collector purge the allocated memory to your app, and then yeah, ultimately it leads to poor performance, or yeah, causes eventually your app to crash. Let's see how using memory profilers look like in Android Studio. Yeah, I'll be using the Firefox app again. And let's see. Let me close this tab. Uh, Let me relaunch it. Now we go to Profiler. We stop all of the existing sessions so as not to get confused. I click on the plus button over here, and then I click on the process. And this time, let's click on memory instead of CPU. Now, immediately you would be seeing the entire memory graph to be divided into separate sections: Java, native, graphics, stack, code, others, and stuff like that. Now, yeah, we are definitely interested in finding out how our app deals with memory when it comes to the broader operating system. When they say native over here, it means like stuff that is written in C or C++, and it is mostly like dealing with the lower level operating system stuff. If your app your deals with like accessing Bluetooth or camera and stuff like that, all of those memory allocations go to the native stuff. Uh, if I were to, so we learned about like what an app heap is. So if we were to find out how our app heap for a particular app looks like, so I'm gonna click, yeah. The thumb rule is you start doing all of the operations which you expect to do on your day-to-day basis for your app. So over here, let me go ahead and play around with the Firefox app a bit. I'm going to open settings. Let's see. And yeah, I'm gonna do some pretty random operations here. Let me see what are the add-ons. Let me go back, and yeah, let me search for hello world this time instead of just hello. There you go. Now, if I were to see how much memory was consumed by the app over this entire course of time, and you can see the graph is already started to change over here. I click on capture heap dump, and I click on record, and I do not need to click on, because when I click on heap dump and record, it takes all of the historic operations into account. whatever screens you have visited, how much memory it has consumed till now. And then over here, information organized in the memory profiler is relatively simple compared to CPU profiler. And CPU profiler, sometimes it gets overwhelming if you don't know how to navigate around it. But over here, it's pretty much straightforward. The drop down over says view app heap, all heaps, zygote heap. Zygote heap is everything related to Linux terminals, like Linux kernels, the underlying operating system stuff. That can get quite complicated, but for the purpose of this talk, we would be just looking into the app heap or the amount of memory which is being consumed by our app or the Firefox app. So I'm going to select view app heap. Over here, you can see it's show all classes, show project classes, and activity or fragment leaks. Show all classes is going to show you the default classes, which is part of the Android framework library. You can see android.view, android.widget, and that is taken care by the operating system itself. For uh, if you were to add memory your piece of code is, then you're gonna go ahead and select, and yeah, has it loaded? Yeah. And then you can see by default all the classes in this project or this particular app has been arranged as per the retent. Now, there's a concept called shallow size, and there's a concept called retain size. A shallow size is the size of the object itself, a browser cache, or like a home activity, root linear layout, or crash content view. A retain size is of the object itself plus the object which is getting retained inside. If browser is holding reference to, let's say, X object or Y object or Z object. So browser cache plus X plus Y plus Z, that gives us the retain size. Now having these kind of visualizations in the app makes sense in analyzing like, oh, how does the memory allocation in my app looks like, and is there a chance of like potential out of memory errors? Should I be concerned about fixing any of those? And navigating to individual files over here. So if I on a particular class name, it is going to give us detailed information over here. So depth signifies like what level of that object in the heap. If the depth is like too deep, it should not be like immediately concerning to you, but you should be keeping an eye out, because in case of garbage collection, all of the nodes which have like higher level of depth are more prone for memory leaks. If it were like upper level depths or something, then the prone for memory leaks is particularly low. Now, navigating around the code base from here is pretty easy. Like right click or double click, and then click. It will take you to that particular file over here. I wish I could show you a memory leak in this app, but the Firefox team is like really active and they fix their memory leaks like almost every day. So I would recommend, like, if any of you are interested, like how a memory leak looks like, you can search for directly Phoenix memory leaks, and probably throw in a term like GitHub, and then in the issue page you can see what was the exact. So there was one of those issues which occurred back in July, memory leak when navigating into recently closed tabs. And yeah, and they fix it, like they fix it in probably a day or two. They have a really good team.
I have a question.
Yeah, go on.
That's a very good point you brought up, and I was wondering. Sometimes I used to work for a company where we were building air,
Mm-hmm.
and we had so many memory leaks based on third parties. And I'm wondering, is there a way, like you can solve those problems that the third party memory leaks? Like, how do they navigate that if you know of any? Because it really bothered us because you cannot fix it their library, but there are memory leaks that are affecting us.
Yeah, that's a good point. Even I have been there where like third-party libraries have memory leaks and everything. So what we do, we generally reach out to the team, but that also is like, it's like kind of a gamble. If the third-party library is being developed by a team like Square or something, they take immediate action. But the other thing what we have done is we start definitely putting together like a small team which would be building something like in-house alternative to that particular third-party library. Yeah. I hope there was a better approach, but that was not.
It was
Yeah,
simple.
I know. Yeah. Yeah. Uh, yes, I think, yeah, those were all the slides. And that is what I wanted to present.
Cool.
Thank you.